Our molecule is one of the 18 chemical syntheses from the lab of Dr. Aiden and Dr. Ozen. From the NMR spectrum and the IR spectrum, we were able to determine that our molecule is benzaldehyde, which has a formula of C7H6O and a molar mass of 106.121 grams per mole. The NMR spectrum we were given showed 3 different signals, which suggests 3 different chemical environments. However, the NMR spectrum that was generated by ChemDraw had 4 different signals, which suggests 4 different chemical environments. But based on the structure of benzaldehyde, we can see that the first signal, which both NMR spectrums show at around 10 parts per million, correspond to the hydrogen attached to the carbon that is double bonded to the oxygen. This has the highest chemical shift because the C double bond is really electronegative, so it causes the chemical shift to be higher for the hydrogen that's directly attached to the carbon. This signal should only have 1 peak because the neighboring carbon atoms don't have any hydrogens attached to them. The next peak is at around 7.85, which also match up with both NMR spectrums. This signal corresponds to these 2 regions of the molecule, which are both in the same chemical environment and experience less deshielding than the first hydrogen, causing it to be at a lower ppm, but more than the other ones that are further away from the C double bond. They are both in the same chemical environment because they're attached to 2 carbons, and one of the carbons doesn't have any hydrogens attached, but the other one has 1 hydrogen attached, so it means the signal should have 2 peaks. And then the last 3 hydrogens of the benzaldehyde molecule are also in the same chemical environment. They are each attached to 2 carbon atoms, which are each attached to 1 hydrogen atom, which means the signal should have 3 peaks, since each hydrogen is being split by 2 other ones. This is what the NMR we were given shows, 3 peaks, but then the ChemDraw NMR shows an extra peak, which can be explained by how maybe the C double bond was deshielding the last hydrogen less than all of the rest of them, causing there to be a slight difference, but ultimately they're in the same chemical environment, so the signals are really close to each other.
Looking at the IR spectrum for our molecule, we can see that there's a CH bond around a wave number of 700, a CC bond around a wave number of 2850, a C double O bond around a wave number of 1700, and a C double C bond around a wave number of 1500.